Hello again, guys. Now we enter in the world of couples. That means we need couple therapy. Yay. Okay, what is a couple? In statics. In statics, couple are just a pair of forces, equal and opposite, parallel to each other. Meaning there's a perpendicular distance here between them. And if that is the case, those two forces produce a pure moment, which is just force times the distance, being the distance the perpendicular between them. I have a video on this where I explain exactly what a couple is and I put several examples. So let's apply the principle. You can do this in the traditional way, force times distance, force times distance, force times distance, add them up, calculate the moment. But if you have couples there, it's super simplify the process. So basically, this is what happened. These two forces are causing a rotation like this, because this force is pulling, this force is pushing, a rotation like that. It's a moment, right? And force minus force, they goes in the same direction, parallel to each other, but different direction, or different sense. Then when I add them up, it's going to be zero. It's a pure moment. Same thing happens here. So the only thing we have to is assume the rotation. I'm going to say counterclockwise as positive. I'm going to start with this couple of forces, 200 times the distance perpendicular to both of them is given here, 1.5. And what about the rotation? If I push and pull, this is going to be the rotation, this is going to be positive. And then we move to the other one. And this part, there are two ways of doing it. Well, several ways of doing it, but let's say the most obvious would be I decompose these two forces in these two forces, and this force and this force are the components of this one. This will be F cosine 30, and this will be F sine 30. Same thing with this, and same thing with that. But these two goes equal and opposite in the same line, so they cancel each other out. Meaning the only force that is lasting here is this one, which is force cosine 30. Remember, force is 125. And I have to multiply this by the distance between them, which is given as 1.25. On the rotation, if I apply this force in this way and this force in this way, it's going to rotate like that, and that is positive as well. So we just have to solve that, and that will be 200 times 1.5 plus 125 cosine 30 times 1.25, and that will be 400. 40594.94. What units are these? Pounds per foot. Pounds per foot. Oh no, that's too big. That shouldn't be like that. I mess up here. I don't know. Let's check. 200 times 1.5. Yeah, of course. 200 times 1.5 plus 435. That sounds more plausible. You know, I just realized it because how come you have a force of 200 and a distance of 1 and going to produce 4,000, 40,000? It's impossible. So 435.32 pounds per foot, that sounds more acceptable value, and I hope that is the correct value. But we're going to demonstrate that anyway. Now remember I said this could be solved in a different way. Well, the different way that this could be solved is, I'm going to keep the same one. The first part, I'm going to keep it the same, and I'm just going to put that force here, and the other force here. That's what I'm going to draw it here even better. So I'm going to put it here. So I have this force, and this force, and this is 30 degrees, and 30 degrees, and this distance is 1.25. Good. So we decompose this force, but instead of doing that, I could have just worked out and find a perpendicular distance between this force and this force. I know this is 125. I know this is 30, meaning if this is 30, this is 60, and if this is 60, this is 30 again. Meaning this distance is going to be 1.25 cosine 30, and the problem will stay the same for these two, 200 times 1.5, but now it will be the value of the force, 125, multiplied by the distance, and the distance is 1.25 cosine 30 degrees. Now if you compare this with that, it's exactly the same thing, right? The force is 125 cosine 30 cosine 30, 125, and that should be 435.32. So two ways of doing the same problem. Hope you like it, guys. Keep watching and keep learning amongst all. Have a good day.